Hello everyone, my name is Daivik Gupta and I am presenting my final course project for data visualization course, and my project is creating a data set based on AI startup funding and success matrix. So talking about the data sources that I used Crunchbase Global Startup Genome Report from 2024, CB Insights State of AI Report 2023, PitchBook Venture Capital Outlook 2024. Also, because we are focusing on AI based startups, so I have limited the data from 2018 to 2024. Now, a bit of insight on why I chose this topic. Basically, global AI startup funding has surged from around 25 billion annually in 2018 to over 90 billion in 2024. So this is a huge growth in this sector, and we try to understand the factors that correlate with startup success, such as funding size, founding team experience, geographic region, and sector focus. So this is a rich and practical data science problem with real business implications. This is our data dictionary that we'll be using in our dataset. So we begin by importing our standard libraries. All the libraries are standard, nothing fancy here. Then we define master reference list. So we define all the categorical vocabularies, weights, and helper structures. Also, a point to be noted here is that we use realistic weights, not uniform distributions, that make data far more realistic. In order to explain this, I'll take an example. Like for example, North America, being the hub of the IT industry, receives disproportionately higher shares of funding compared to any other part of the world. So here we define countries and we set their weights again depending on the realistic scenarios. Then we define region maps. We define various sectors. Again, the weights assigned are based on realistic checks and not uniform distributions. Then we define various funding stages. Now funding can vary a lot depending on the funding stage. So we have defined the funding stage here, and then we have defined a range of realistic funding in USD millions for each of the funding stage, and then we have defined a range of number of each funding stages that companies usually undergo for different stages. After that, we have created a conditional probability matrix or different for different funding stages depending upon active, acquired, IPO or failed. Also, a little note here that the IPO stages forces outcome to IPO as IPO is the final stage of the funding process. Then next we build helper functions. So in order to keep our notebook very modular and to keep the generation loop readable, we define some of the helper functions that will help us generate our dataset. So a few of the correlations that we build are total funding USD, that drives employee count, annual revenue and valuation. Funding stage, that drives total funding, number of funding rounds and outcome. Deep tech, this is the binary question because it boosts the number of patent counts significantly. Then having a government contract also has a lot of influence on the funding process. So that is a binary metric that we have added. And then the founding year, because the last funding date is always after the founded date, and the founding year the company age influences the type of funding heavily. So now here we have defined all the helper functions and we have defined all the metrics and variables. We'll be calling these functions when we'll generate the dataset. So now we have defined all the helper functions. Now we will generate the dataset. So now we run the main generation loop, and each iteration produces one startup record, assembling all the correlated columns in a deliberate order so that the downstream variables can depend on the upstream ones. So we start our loop here. We define identity, geography, sector, temporal, funding stage, funding amount, number of funding rounds, team, boolean flag for the deep tech, and the government contract, patents, revenue and MAU. MAU is basically monthly active users. Outcome, valuation, which depends on outcome and stage. Like this is a downstream variable and it depends on the upstream ones. So this will be generated after outcome and stage. Dates, and then we assemble all the record and we build a data frame. So when this loop completes, our dataset is generated. As we can see, our dataset has 1200 rows and 20 columns. Then we validate the dataset. So basically we perform quick sanity checks to confirm that there are no unexpected null values and the column types are correct and that the distributions look realistic. So here we have defined a few of the sanity checks for shape, data types, missing values, categorical distributions, numeric summary, and correlation check. Now this is the output of this cell. We can see all the data types which are in line. We can see missing values which are approximately 327. Then outcome distributions, categorical distributions, and top 5 countries and numerical stats. So now we have checked all the sanity checks and the dataset has passed all the checks. Now we preview the dataset. Like for manual checking, we print first 5 rows of the dataset and then random 5 rows of the dataset to take a look how our dataset actually looks. So as you can see, this is an insight on our dataset, how it actually looks. So now this is it for now. Okay, in last step we export the CSV file so that we can use it in our next notebook, in which we'll be creating visualizations based on the dataset that we have created. So this our notebook 1 is complete, and now we will look at the. Okay, so now we move on to notebook number 2, where we'll be covering the visualizations, and we will do a bit of EDA based on the dataset that we created in notebook number 1. So we have prominently 4 research questions that we'll cover below, and the tools used are very basic: Panda, NumPy, Matplotlib, Seaborn. So firstly we import our libraries and we configure our plot styles. Then we load and inspect the dataset. We can see our dataset, column names, data types for each column, and number of non-null entries, and numeric summary of our dataset. So now we start with a little bit of pre-processing in our dataset, as the 2 columns, particularly total funding and annual revenue, these both are heavily right skewed columns, which is a common pattern in real financial data. So we apply a log transformation to reduce the skewness. As we can see, applying log transformation reduced the skewness of total funding in US dollars from 3.35 to 0.34. So this was a highly effective measure in reducing the skewness. So coming to question number 1, which is how is total startup funding distributed? We use a kernel density estimate plot overlaid on a histogram to answer this question, because funding data is heavily right skewed. Again, we plot on a log scale to reveal the true shape of the distribution. Also, we overlay the vertical lines of the median and mean to highlight the skewness visually. So this is the very basic code to plot this, and here is the our plot visualizations. Now I won't be covering insights because of the time constraint, but I'll be summarizing the insights at the end. Okay, coming to question number 2, does higher funding translate to higher revenue? We'll use a scatter plot with a linear regression light, again via seaborn.reg plot, which is the appropriate tool for exploring the relationship between 2 continuous variables. Also, we will color code the points by funding stage to differentiate between different stages. This is again a very basic code. So here is our plot. On left we have overall funding and revenue relationship. On B we have funding to revenue colored by the stage. Again, I won't be covering the insights right now because we are under time constraint, but I'll be summarizing the insights at the end. Next question is, which AI sectors attract the most funding and how variable it is? So we will use a violin plot and a KDE, which is a kernel density estimate, showing the full distribution shape, which makes it ideal for comparing continuous variables across many categories. Also, we sort the sectors by median funding for maximum readability. This is the code for it, and here is our plot. As we can see that supply chain AI and edtech AIs, they lag significantly, and the generative AI fields are much ahead than other fields. Again, insights would be covered at the end. Finally, our last question is, which numerical variables are most correlated with each other? So a very basic correlation heat map was the perfect choice for this question, and now we will plot our heat map. So here is our heat map. So these are the insights. I'll cover all the insights in a very quick way. So the first question was, how is funding distributed? So our key finding is that it is heavily right skewed. IPO of startups are the outliers at the top, and failed startups cluster at low funding levels. Does funding drive revenue? Yes, We saw strong positive correlation as the line was having a positive slope r approximately equals to 0.80, which was mediated by the funding stage. Which sectors attract most funding? As we saw, autonomous systems and generative AI lead in median funding, whereas edtech and supply chain AI startups, they trail significantly in this regard. Lastly, what were the key numeric correlations? So, funding, employees, revenue, and valuation. These four data columns, they form the strongest correlation chain in the dataset. So these were our key findings from the dataset and the visualizations that we did. Coming on to the potential next step, which would be the future scope, we can train a classifier to predict outcome using different data columns such as total funding, sector, region, geography, employee count, valuation, etc. Time series analysis. We can analyze how funding trends by sectors involved between 2018 and 2024, which can help us predict the future uh, output of the whole sector at large. Lastly, survival analysis. Now we can apply a Kaplan-Meier curve to study the time to failure versus time to acquisition as a function of funding amount that can help us understand the survival chances of startup at each funding stages. So that was it for my project. I hope that you guys liked it, and personally I find it very usable, and yeah, I think that this dataset can be published and used significantly in real life